This is another podcast from the ICE, and this time we're discussing the energy transition, more in particular about hydrogen and nuclear with Mott MacDonald. We have Jamie, Paul, and Lewis with us today. And to do an introduction to both of them, Jamie, he's focused on hydrogen power to X and liquefied natural gas development at Mott MacDonald. And Lewis is the experienced head of business, project manager, and a consultant with experience across international nuclear sectors, covering the commissioning, advanced reactors, and fusion technology. Over to you both. Who wants to start and let me know a little bit about what your work day to day looks like?
Yeah, I'm happy to kick things off. So good to meet you, Irene. Lewis McVey. My day to day is diverse. The thing I love most about nuclear. Um, but more focused on what I actually do. My day job is the business development director for civil nuclear at Mott MacDonald. But then I am also project director on a number of our strategic opportunities and projects around the globe that we're delivering. Jamie?
Thanks, Lewis. Yeah, hi, Irene. My name is Jamie Paul. I'm the hydrogen and LNG lead for business development, as you mentioned, and my day-to-day is similar to Lewis. It's a combination between business development and business development. Hydrogen is as much trying to encourage the market to develop and adapt, influence policy as it is to get projects going. And then on the other aspect of it is that I work on some of our key projects, generally as engineering manager, leading the technical team to deliver them, whether it's onshore, offshore hydrogen or liquid hydrogen projects.
Can you talk about any projects you worked recently or there were of particular interest?
Yes, for sure. We've been working extensively in the Netherlands. So we've completed a suite of projects that started off with the North Sea Wind Power Programme, which was a consortium for Hassuni, EnergyNet and TenneT, which are the gas network operators and TSOs in the Netherlands and Denmark. And we were looking at how do you integrate offshore wind generation with hydrogen to maximize your revenues and maximize your energy recovery. So we were looking at onshore solutions at the sort of gigawatt scale hydrogen production, as well as offshore solutions, whether that's on an artificial island or platforms or even local to the wind turbines. And it's how do you integrate the hydrogen to make sure that you avoid the curtailment of the wind, which costs a fortune in countries around the world at the moment when your peak production exceeds demand or transmission capacity. And then how do you then incorporate that large scale energy source that you need, or any energy storage vector that you need, which probably is hydrogen, and then how do you incorporate that into the onshore economy? So that's a lot of the work that we've been doing recently.
Is there any parallels you can draw, Lewis, with hydrogen in terms of projects, or is it a similar approach, even though they're completely different energy sources?
Yeah, absolutely. So I suppose one of the key projects I've been involved with most recently would be with our friends at Holtec. So they are a technology development company from the United States. But they were looking and are still looking to bring their small modular reactor technology to the UK. So one of the first parts of that is to go through the UK regulatory process with the Office for Nuclear Regulation, a process that's called the Generic Design Assessment. So we worked with Holtec, and I was the project director on that project to deliver the generic design assessment in the UK. So really taking the work that they've done in the US and contextualizing it for the UK. We have a different regulatory regime here that we could spend all day talking about, so I won't get on that soapbox. And so it was a great piece of work. It's a stepped process, so there's 3 steps within it. And I was really proud of ourselves and of Holtec because we were the fastest ever step 1 to complete. We were 15% quicker than we anticipated being, and then we were 65% quicker than some of the other GDAs for step 1 in the past. Now, we can't take all the credit because we did take a lot of learning from that past GDA. We have been involved in GDAs for all of the current and not so current reactor designs in the UK. So we took a lot of that learning and transferred it into Holtec, which allowed us to then really hit the ground running. That's probably the one I would pick, particularly because we're touching on energy transition. So.
And from your point of view, of course, you're from different backgrounds, but somehow you're helping together for the energy transition. From your point of view, is nuclear getting bad publicity, or is getting less popular, and is hydrogen on the rise? Because I remember when I first started studying, 20 years ago, I didn't hear about hydrogen. I had no idea. But obviously you, Jamie, have been in the business for probably that time. So what are your opinions on the current perception of both?
Yeah, I mean, from a nuclear perspective, I think approval within communities is rising. Whether that's wishful thinking, but I genuinely believe that. I think we're in a very different position now to where we were when I first started in nuclear. It was very quiet. Well, there were no new build projects when I started. It was all decommissioning and current operations. Whereas now we have 2 gigawatt scale projects being built down south at Hinkley Point C and Sizewell C. We have Great British Energy Nuclear that are looking to deploy small modular reactors in the UK. And then we have a series of events, of opportunities as a country of private partnership between technology vendors and other sort of energy users that we've not seen in the past. And you will have probably seen a number of announcements within the last couple of weeks, particularly around the state visit from the US, where those partnerships between very different worlds are forming and are really progressing not only the nuclear cause, but also data centers, alternative or synthetic aviation fuels, etc. And it's quite game changing for the industry as a whole.
Good to know. And I'm guessing, well, in the industry, again, you have standards, you have legislations you have to follow, and obviously you need to comply to them. You need to be having an open mind and be on a constant changing environment just to improve and make sure that things go the way you want to go. What about you, Jamie? What do you think of hydrogen? How has he evolved from the last few years to now? And do you see anything in the future? Do you think it's got potential? Is it going to change, or is it just hard to tell at the moment because it's an emerging source?
Yeah, hydrogen's been through a roller coaster ride in the last few years. Hydrogen's always existed. Hydrogen's always existed, but the production of hydrogen has been part of refineries for a century. The technology is old. But then the recent energy transition, the desire to use it as an alternative fuel source, a low carbon fuel source, sort of went through a wave of excitement in the last 4 to 5 years, where there was funding around the globe. Everyone was progressing. Everyone was looking at converting at gigawatt scale so that we can transfer large scale energy production potentially to be the base load production for electricity from natural gas to hydrogen. Then more recently, partly due to sort of global trends in terms of the focus on the energy transition coming out of America and others, there's been a sort of consolidation of hydrogen. We've got to the point where people have looked at the designs, they looked at all the different use cases, and whilst hydrogen can theoretically solve almost every solution that natural gas can, is that cost effective? Is there a real business case for it? And in some cases where the excitement was coming, where people were looking at it as a solution, it doesn't provide a cost effective solution. But the concern for me is that there's a loss of focus on the energy transition. And sometimes there's a tendency to say, is it cheaper than natural gas for a particular purpose? And of course, not necessarily, but ultimately we have to stop using natural gas. So there are projects going ahead now. They're still being funded. There's rounds of funding in the UK and Europe that is leading to onshore green hydrogen production. And that, especially where you've got a dedicated off-taker that's confirmed, is happening. And then and there's a lot of work going on in pipelines to sort of build in the east of the UK, in Germany in particular. They're building up, and to a degree the Netherlands, they're building their onshore hydrogen network, and that will become the basis by which you can develop a wider hydrogen economy. And but you're seeing a sort of delay in, say, offshore hydrogen production, which is potentially absolutely essential for the recovery of offshore wind, but it's been delayed. Realistically, it's been pushed back a number of years. And then you never know where it goes with hydrogen. So I wasn't really, until very recently, wasn't considering that liquid hydrogen would be something for it in the short term, certainly, but maybe in the medium term. But actually, in reality, we're now working on liquid hydrogen projects, and we're seeing that, and that is potentially going to be the vector for the transportation of hydrogen around the world. So you never know with hydrogen. It will form some part of the solution to the energy transition, and the exact use cases are still being worked out. So, but it's part of my job to try and keep pushing it and hope and finding a way that we can do it.
Exactly. I think that means good news for you both, because it's part of your job to get things going and get kicks in, and talk to policymakers or anything. Do you get to talk to policymakers? Are you involved in any way on how to shape the government policies, or is that something that you are not really involved with?
I mean, from a hydrogen perspective, yes, absolutely. We attend hydrogen roundtables. We engage with key players such as the pipeline operators to make the case, for example, that hydrogen transportation is much cheaper than the transportation of electricity. And maybe that is a use case for hydrogen. Even if you lose some efficiency in converting it to hydrogen, you can move it around the country much more cheaply. And we've been engaging across Europe. And so we're speaking to the Hydrogen Italy, for example, and they're keen to bring our expertise in to push there. So yes, we're very involved in trying to push policy making as well as wind projects, of course.
Is that the same case for nuclear, Lewis, as well?
Absolutely. And again, it's very much changed over the course of the last, handful of years. Whereas it was a periphery activity with a periphery interest within policymakers. It's now much more broadly supported. So each year there's a big conference called Nuclear Week in Parliament, hosted by the Nuclear Industry Association, where we get to go and engage with MPs, with decision makers, with Lords, to really tell them about the positives that we see from our industry, the developments we're seeing, their roles, and I do not envy their roles in terms of being across such a breadth of things. It's the easiest way to define it. So it's really our job is to get to pass that message on. The innovation that we're driving within the industry, the jobs that it's created. I mean, in the UK now, we're touching nearly 100,000 nuclear jobs in the UK,
wow,
which is a phenomenal growth from where it was 20 years ago. It's a phenomenal, I think it's an 11% growth in the last year or so. I will have got my figures wrong on that growth, but we'll run with it. It's a massively evolving picture. There's a lot more buy-in from governments, but not just here in the UK. So we've been working with governments from around the globe, helping them understand nuclear. Some countries have been nuclear but haven't really done it recently, so they need to refresh themselves. And then, really interestingly, countries that have never been nuclear before, as part of this energy transition, net zero energy security, are really looking towards nuclear now. And while those countries haven't made decisions that they're definitely going to go down that route, they're engaging from policy level right through their supply chain. And because the UK is, we were the country with the first commercial nuclear reactor in the world. We were the first. Wow. Up in Calder Hall in Cumbria. It was the first one. I think the Queen opened it really early on in her reign. So we've got such a breadth of experience in the country that it puts everyone in a really good position to then export that knowledge around the world. So it's really exciting. If we'd had this conversation 20 years ago, I think it'd have been a bit more dour.
And it is really good, because that's what we need, is to get the conversation started, isn't it? It's not about the country signing up for nuclear or hydrogen, like they're signing up for a subscription, but
Yeah,
it's getting the conversation started, at least getting that bug in their minds, in the back of the head, saying, oh, what happened if we do this? So I think just that is a great win, and I will take it as a great win. So you
absolutely.
mentioned you have projects, you work with projects, for example, in Europe and especially America, as a good ally for nuclear and hydrogen. They're both on board. What happens on the other side of the world? What happens, for example, with Australasia? Are they kind of similar mindset, or are they quite opposed to it yet because it's not quite developed?
Yeah, so there is there's a small but growing campaign in Australia, as an example, um, run by a really inspirational and probably one of the smartest people I've ever met, Will, running that campaign. And it's really a grassroots movement. He's a young chap, and he's identified from his own life that he believes in nuclear. So he started that campaign. There is a long way to go, I think, in countries such as Australia. But then if we look to other countries around the world, the Singapore government have recently announced a contract to study whether nuclear is right. And again, they've not made the decision that it is, but they're having that conversation. They're going to make a decision from an informed viewpoint rather than a baked in disbelief in the technology. So I think the conversations are happening around the world to varying levels with varying success. But it's certainly happening.
Is that the same in the case of hydrogen, Jamie, that you've seen or noticed, or it's more Europe and America sort of centralized at the moment?
Well, at the moment, I mean, America is pushing back against the sort of transition, so that's less of a focus. Europe is ahead, probably was the first mover in terms of the rollout of hydrogen, but we are definitely in the Asia Pacific. As everyone knows, Japan and other countries in that region don't have their own local energy resources, and so they are large-scale importers of energy, which typically be LNG at the moment, or historically coal. And so there is a lot of engagement from the Japanese government about what low carbon energy vector will replace LNG ultimately. And so we have an office in Japan, and we've been engaging with them, and the first green hydrogen production projects in Japan are starting. There's one in Hokkaido and probably others elsewhere. And there is also a lot of engagement with studies into how they might bring, say, hydrogen generated elsewhere to Japan. So there's a lot of work in India. They have a large-scale fertilizer production industry, and so that's producing ammonia. Ammonia is a hydrogen vector, so there's a lot of studies into whether that ammonia could then be transported to Japan, either converted back into hydrogen for power generation or power generated directly from the ammonia. There's other carriers. I know there's a study in Malaysia. There's a carrier called MCH, which is methylcyclohexane, and you add the hydrogen to it, and it goes back to toluene, and it's a means of getting the hydrogen there. And then also, as I was mentioning with the liquid hydrogen, the world's first liquid hydrogen project is, I believe, from Australia up to Japan. There's actually operating with liquid hydrogen ships doing that route. So that's an area that they're looking into. In terms of hydrogen production elsewhere, in South America, there's a lot of what you want for hydrogen production is consistent, large-scale, cheap, renewable production. And so in places like Brazil, where they have hydropower, there's one of the regions in the north, they've got a large hydropower capacity and not the demand locally. And so they're looking to produce hydrogen at scale, convert it into some kind of carrier and supply Europe from there. And then ultimately, in the long term, the countries that are large-scale energy producers now, like the Gulf states, like Australia, like North Africa, they also have huge potential for solar and renewables. And so potentially in the future, you can imagine that the hydrogen will produce there is transported around the world in much the same way as the oil is currently.
Yeah, that's true. We're focusing on hydrogen and nuclear, but yeah, let's not forget that there are other renewable sources that, of course, it's almost a competition as well, isn't it? That you have to, you're not the only ones in the market, so you have to find a way, as you mentioned before, Jamie, that is relatively cheap or it appeals to people, and it's easy to carry out and easy to do. So what do you think it will be the main blockers for adopting a certain strategy in terms of hydrogen? What would be the main stop? Will it be policymakers, or would it just be knowledge, for example, because it's relatively on the rise right now? I know you mentioned it's been, hydrogen has been there forever, it is, but as a green technology, it's quite new. What do you think it will be the main blocker that you as business developers should help with that?
So I think that you're trying to start a hydrogen economy from scratch. You're trying to identify sources, install the infrastructure, and identify off-takers all at the same time. So getting people to commit to a project as off-takers when the project doesn't exist is very hard, and getting people to fund hydrogen project when there's no confirmed off-taker is very hard. So on individual projects, there probably are projects that can be economic once they overcome that hurdle. And then what you need is the large scale infrastructure. So if you had a relatively simple solution would be for the government to go ahead and give a confirmed maximum possible acceptable blend of hydrogen into the pipeline network, and then that can be the anchor off-taker for all these relatively small hydrogen projects. They can, if they can't find other off-takers, they can put it into the grid, and that would get it going. The other challenge is that, as in the energy transition, the decarbonizing the power sector has relied on the fact that renewable generations come down and down in cost until it competed with the competitors and actually genuinely is the lowest cost option. With hydrogen, due to its drop in the efficiency losses in production, it will always be more expensive than simply burning natural gas. But yet there will be certain, let's be optimistic and say by 2050 we genuinely are net zero. That net zero world will have to have a large scale energy storage vector, which almost certainly is hydrogen. So at some point, either there will have to be some kind of carbon tax on the alternative fuels or funding from government to get there. So partly individual projects will be able to get going with support, but probably needs to be some acceptance that we have to move away from hydrocarbons, and that has to be funded in some way.
Yeah, that's it. What about nuclear, Lewis? What you will say is the main blocker or the main blockers in terms of advancing forwards?
So I think that there are a couple that we could pick up on there from the emerging countries developing their supply chain, and their regulation is a challenge, but we have examples from around the world of where that's been achieved. You just have to look at the UAE and what they achieved in partnership with the rest of the world. And it is, it's a global energy transition challenge that we're facing. So it's global partnerships required. But I think the fundamental main blocker to most people's acceptance of nuclear is the perception of risk, the perception that nuclear is inherently dangerous and that it's going to kill lots of people. Everyone will hold up the Fukushima example, in which no one died of a nuclear release. Obviously, it was a tragic accident, but there was no nuclear deaths as opposed linked to it. And I think you just need to look at data from around the world that nuclear is, it's on a par with wind and solar as the safest form of delivering mass energy. Particularly if you look at like death rates per unit of electricity produced, they're all in that sort of bracket of 0.02 to 0.04 death rates per unit. Whereas if you start looking at things like oil and gas, they're up at the 20s. So it's like 500 to 1,000 times different it's safer, I guess, than those that we've used so much in the past, when you take accidents and emissions and all of those things into account. So I think it's the perception that it's fundamentally and inherently dangerous, but actually reality isn't. It isn't dangerous as long as we manage it appropriately. And there is, it is inherent in everything we do in nuclear. We have safety as a part of everything we do. I'm not saying others don't, but it's fundamental. We have to account for every ounce. Sorry, I shouldn't use ounce. Every gram of waste that we produce, we have to account for that. We have to record it on a system. We have to manage it, and we have to declare where we're going to send that for disposal. So it's, you know, it's an accountable industry. It's a safe industry. And I think once we can start those conversations and get policymakers, and more importantly, probably the public's perception changed around that, then I think we're on to a winner. And I don't think nuclear won't be the be all and end all. It's part of the mix for the transition. It provides that stable, long-term base load that we always talk about. And it can very nicely link in with the hydrogen production and other areas to provide that base load for them. It can decarbonize data centers. It can, but until we get over that hurdle of people's perception of the risk, well, sometimes it's like shouting into a dark room.
I do agree with you, Lewis. Actually, I 100%, because for me, even though I'm on the geoscience field, so I got, I know about this and how good it is to go for the energy transition, etc. I'm also a public, and I got my perception as well, even though from a scientist point of view, right? But you're completely right. I was always like 50-50 with nuclear, but because of the risk, because even though we're working on the same field, I'm not an expert, so I'm not 100% informed, and then that's the problem when people like me, for example, that they really don't have any advice on it, make the decisions. They do it on their own perception rather than people who are actually working on it and explaining how the health and safety is brought up, as a quality check and a success measure as well. So it was really good point you made, because I think that would hopefully help understand, as you said, public perception as well, because if you tell somebody they're going to build a nuclear reactor, I don't know, 10 meters, obviously not that close, but like stone's throws away from the house, they're going to be panicking, they're going to be protesting. So it's good to have the public informed as well as policymakers. Is very good, because everyone needs to be on board, and we need to understand that those are steps we need to take in order to achieve the energy transition and be net zero by 2050. So it's all measured in, in terms of how much we do. So I think it was a very good point. So thank you for raising it. I think it was very good.
I think the other point as well, really, and Jamie touched on it, is the cost. People focus on the cost a lot of nuclear. There are big numbers thrown around for some of these big mega projects. Some of the largest construction sites in the UK are nuclear new build projects. But what people don't understand, or what people, we've not explained properly, is that these projects, we're going to build Hinkley Point C, and it's going to run for at least 60 years. By the time it actually closes down, it's going to be probably 80 years. With plant life extension, but the fundamental safety case is based around about 60 years. So that's 60 years of carbon-free energy production. Perfect. And then when we dig into the costs that build up to the overall cost, only about 12%, somewhere between 10 and 15, let's say, rather than be accurately wrong, is the actual capital cost of the work. Another 10% is for the lifetime operational cost and decommissioning. But 30% of the cost is the cost to finance the build. So if you start to take some of those big chunks out through through a fleet-based approach, through looking at smaller reactors, so the SMR, small modular reactors that I mentioned earlier, where the capital costs come down, the risk is smaller, therefore that percentage can reduce, which means our price point is reduced too. There was a throwaway comment made when they first open called the hall that it will be so cheap to produce this energy we could give it away for free. Now that was a political statement that never actually bore reality. because you then have to factor on, it is cheap to do, but then we have to manage. But I think cost is the other element too, that is a barrier to people's acceptance.
It is definitely. So we talk about the pros and cons, I think, roughly of each alternative. We talk about the perception of people around the world as well, how they are, going forward. I think to close this, I would like you both, if you could say first, what do you think it would happen in the future? How do you see the future on moving forward? And if you could tell the future generations that are now going into college, for example, and they watch this and they're like, oh, I want to do that. How do I do it? Would you be able to provide some advice as well? Just for people trying to move forward into this and be the next Lewis maybe in 20 years, or the next Jamie in 20 years or 10 years.
Yeah, I mean, from my perspective, what does it look like in the future? I think there's going to be a growth in nuclear production, energy production around the globe. I think we're going to see much more private partnerships, as I mentioned already, forming, where the off-takers are partnering their project with the power production, which again allows a different business model, which again could reduce the overall capital costs. I won't get on that soapbox, but I think we're going to see a massive growth in new nuclear. I think we'll see development of new technologies. I think we'll get to the point where sort of industrial areas, high energy use areas, high heat use areas will be looking to nuclear as a solution. So without going too much into it, there's a broad variety of nuclear reactors that you could pick from that operate at temperatures from 350 degrees, say, up to 950 degrees. Now, with the heat producing capacity in that broad range, you could do almost anything in terms of the industrial processes. In terms of advice for the next generation, I think there are so many routes into nuclear. It's such a broad field. So yes, going to study an engineering degree or a technical degree or a science degree is ideal. We need loads more people to meet the demand at present. Let's say we're at nearly 100,000 in the UK now. And depending on who you listen to, we need another 20 to 50,000 people to meet current projections over the next 20 or 30 years. So please, if anyone is thinking about it, get involved. But it doesn't have to just be the nuclear engineering. It doesn't have to be mechanical. I'm a mechanical engineer by trade. Doesn't have to be a physicist. We need every discipline out there. From the arts, from business management, right through to policy and government relations. It's absolutely anything, any degree could probably be applied. And again, doesn't have to be a degree. There are routes now. I went through an advanced apprenticeship, I guess it would be called now, but it wasn't called that when I did it, where I worked and got my degree at the same time. But also you could look at, HNCs, HNDs, that there's so many jobs within nuclear. It's a difficult one. My only advice is get into it. I've seen the world. I've worked on projects around the world. I can't see myself leaving nuclear, so I hope it continues.
It's a secure job, more or less,
Absolutely.
What about you, Jamie, what would you say for future generation?
So I think that you can't think of hydrogen in its isolation. I think focusing on hydrogen per se is perhaps the wrong approach. What we're looking at is over the longer term, over the sort of career span of somebody who's at school now and heading out, is that we're moving through a massive change in the energy industry that's going to ramp up like I think Lewis was mentioning earlier. We only solve climate change and energy transition by throwing every solution all together at the problem. No one solution will work. So from a sort of hydrogen and liquid and low carbon fuels perspective, we're going to see hydrogen, we're going to see methanol, we're going to see ammonia, we're going to see liquid hydrogen, we're going to see carbon capture, we're going to see all of this coming together. We're going to see LNG for quite some time yet as well. And so the current doom and gloom a little bit about hydrogen, because perhaps there was too much excitement initially, it was all still funded and there's been a slowdown. Ultimately, hydrogen will absolutely, as part of both a direct fuel and a precursor to other fuels and other energy carriers, will 100% form one of the strands of the solution, like nuclear does, to the energy transition. And so I'm very optimistic about it. We're going through a consolidation. We're working out exactly how to use it, but that's the good thing to happen. You have to find the right business cases for it. And then in terms of kids now who want to get into it, it's probably a science-based degree, I guess, that you would use as the basis for that. But I'm personally a process engineer by background, but obviously we have the full suite of disciplines that can be applied to any of these projects. So if that's the sort of route that you're interested in taking, if that's where your skill set lies, then follow a path like that. Like you do geotechnical, there's engineering, there's science, there's all sorts of routes into it. And my son is perhaps potentially thinking of that route. I don't know, he's quite young yet, but you can imagine it. And I don't want to tell him what to do, but I can very easily imagine that were he to choose a path into this kind of sector, there will be a job for life, because that's what that's what our generation has to do, and that's what the next generation has to do, is basically almost the most important thing. How do we sort out the world and get it low carbon? So I would encourage
100%.
anyone that's keen to find a way, whether it's nuclear or hydrogen or something else, but to contribute if that's where your interests lie.
100%.